me, you can just click it, double click, okay, and then you got this software, and you can open a file, okay, like this test FastQ file, and you can open it. Okay, actually for this file, we can check the format of the FastQ. The first one, okay, start with this character and the sequence identifier. The second one is the raw sequence, and the third one begins with the positive character. And the last one shows you the quality of each base. Okay, and there are many short reads. Okay. Okay. So here, this is the result of the FastQC software. Here shows you some basic sequence statistics, the file name, the encoding table it used, and the total sequences, and the sequence length. And here are multiple modules to show you how good or how bad your seq data are. Okay, and for the software, and here there are some documentations you may use if you have any problems. For example, here when you open this one, there are many detailed explanation of each modules. Okay, here you can always go back here to see or intel information of each modules. Okay, so let's go back here. So the FastQC aims to provide a QC report which can spot problems from the either in sequencer or library. So, and also it is very important to stress that although the analysis results appear to give a pass or fair result, this evaluation must be taken in the context of what you expect from your library. A normal sample, as far as FastQC is concerned, is random and diverse. Okay, as you can see from here, there are many modules. So like here, the first one is the port basics quality. You can see here is not a good one. Here, this one of the right part is a good example, and this is a bad example. And from this finger here, the x-axis shows you the different position of the reads. Here, the short read, the length of the short read is 100, and you can see at the end of this reads that the quality is low, is bad. Okay, then here is the quality score. The higher, the better. Okay, so there are some possible reasons for failure. First, one is general degradation of quality over the duration of long run, and also maybe because of a short loss of quality earlier in the run, or low coverage in case of variable length risk. So what should you do if your sample shows that it have a very bad quality at the end or the beginning of your reads? Usually we will removing those reads, those bases of your reads, use some software. Okay. And this plot shows the deviation from the average quality of each tile, and a good plot should be blue all over like this one. And there are some reasons for errors, like bubbles, smudges, or debris inside of flow cell, or overload of flow cell. And this is the per sequence quality scores module. And the per sequence quality score report allows you to see if a subset of your sequences have unusually low quality values. This is a good example. It shows you that the majority of your reads have an average quality score at 36. And this is not a good one. It shows you that the majority of your short reads have a lower average quality. And here is the per base sequence content module. In a random library, you would expect that there would be little to no difference between the different bases of a sequence run. So the lines in this plot should run parallel with each other, like this one. This is a good example, and this is a bad one. Sometimes if there are some abnormal bases, you should remove them. Okay. The reasons for the errors are like over-represented sequences, or biased fragmentation, or biased composition libraries. And this is the per sequence GC content. This module measures the GC content across the whole length of each sequence in a file and compares it to a modeled normal distribution of GC content. A good example should be like this. So the blue one is the theoretical distribution. So if the red one is looks like the blue one, it is better. And this is not a good example. And when you see a sharp peak on a smooth curve, it means there is a specific contamination. And if you see a broad peak, it means that there is a contamination of another species. Okay. And here is a per base and content. It is not unusual to see a very low proportion of ends appearing in a sequence, especially near the end of a sequence. However, if this proportion rises above a few percent, it suggests that the analysis pipeline was unable to interpret the data well enough to make a valid base course. This is a good example. And this maybe not as good as this one, but it's acceptable. It have a lower proportion of content. And this is the sequence length distribution. Usually our unseq data, the length of each read will have the same length, just like this one. Sometimes, for example, if you have removed some bad bases from the unseq data, you will see some reads that have a shorter length, like this one. Okay. And this is a duplicated sequence. And this module counts the degree of duplication for every sequence in the set and creates a plot showing the relative number of sequences with different degrees of duplication. This is a good one. You can see the majority of the reads have only one unique read. And there is only a small portion of reads are duplicated many times, more than 10 times. Okay, and this is a bad example. Oh, and here this is a good example, and you can also see after you remove all those duplicated reads, the remaining reads still have 95% are the remaining risks. However, for this one, this is a very bad one. And you can see the blue one shows is the and it shows you that there are many risks that have duplication risks that are more than 1,000. And after you have removed those duplicated risks, only 3% risks are remained. So these samples are very bad. You should remove it if you have some samples looks like this in this duplicate sequence module. And also, duplicates could be technical, but can also be biological. So if there is only a small portion of duplicate risk, and it is acceptable, but not like this one. Okay. And this is the overrepresented sequence. Overrepresented sequence may be of high biological significance or contaminants. So you need to check for matches in a contaminant database. And there are also some software you can use to remove some contaminants or adapters. Okay. And also here is the overrepresented K-morphs. And this is a better example. And also there are some softwares you can use to improve your RNA-seq data quality to remove some contaminants or some unnecessary adapter sequence. Okay. And that's all. Thank you.